Welcome everyone. Thank you for joining our webinar on new approaches to automating your central review. I am Francesco, product lead here at QMENTA, and I will be your host today. Please note we are recording this webinar so that it can be added to both our website and YouTube channel for replay. All attendees will receive a follow-up email with a link to this recording, which we welcome you to share with fellow colleagues and industry connection. Feel free to submit any question you have through the chat at any time. We will devote time to a dedicated Q&A session at the end. Today, we will demonstrate how the QMENTA Imaging Hub offers a flexible and comprehensive RANO solution. We will begin by identifying the cost drivers that our solution addresses. Then we will cover 5 different key activities of the QMENTA RANO workflow, from data ingestion to RANO eligibility, where we apply the automated and visual check that guarantee only high-quality data enters your trial, study orchestration and management, and RANO reading in action, automatic brain tumor volume calculation, where lesions are automatically segmented and their volume calculated, quality review and adjudication, and I will not be navigating this platform alone today. I am delighted to be joined by a brilliant colleague, Evie, our neuro-imaging product manager. Throughout the demo, you will see the two of us switching hats to replicate a real-life clinical study setup. We'll be stepping into the roles of the data manager, study manager, and expert reader to show the entire workflow end-to-end. This way, you can see how QMENTA supports every critical user in your clinical trial team. But before we dive into the QMENTA Imaging Hub, let's take a quick look at the reality you're facing. If you manage clinical trials, you know they're not just expensive, they're very complex. Let's look at a few major factors that consume your budget and your team's energy. First, how much time do your data managers waste on manual tasks, cleaning up files, verifying image quality and completeness, and organize data even before it reaches the expert reader? These not productive, repetitive chores are a massive time sink. Second, clinical grade compliance shouldn't be a manual checklist. Ensuring adherence to HIPAA and GDPR with full de-identification and traceability is critical. But if it is not automatically taken care of, it slows everything down. Lastly, longitudinal reading assessment like RANO are complex, and when you lack a centralized structured system to manage the entire workflow, your expert reader spends more time coordinating than actually reading. And these are the inefficiencies that we eliminate. QMENTA provides a centralized single-source reading solution that turns these costly bottlenecks into a seamless and efficient process. We give your expert readers the tool to focus purely on the medicine. Whether you require a full, complex end-to-end central review workflow, or only require specific features like our automated data quality checks or manual reads or AI segmentation tools, we orchestrate these individual building blocks to provide the specific configuration that fits your operational needs. We like to refer to our Imaging Hub as the operating system for medical imaging. It fixes this inefficient workflow by doing 3 things. We automate the quality checks, we standardize data transfer, and we radically simplify the complex orchestration of your clinical trials. The operating system is designed to be built to be flexible and client-centric, to ensure time and cost are drastically reduced. And our Imaging Hub is composed of 2 integrated powerful models: the platform for high-performance data management, automated segmentation and analytics, and the central review model for study orchestration and all your reading activities. This architecture is the result of collecting and addressing real-world bottlenecks. We built it on insights, drastically reducing the amount of manual error-prone activities required for trial management. These 2 models work together to accurately support your entire clinical trial workflow. The workflow not only addresses the identification, but also enables data managers to verify data quality before involving your readers and providing automatic segmentation with volumetric lesion calculation. You will not start from a blank page. QMENTA provides a pre-configured study environment. tuned precisely to clients' needs, allowing your study manager, reader, and data managers to be invited and be productive immediately. I'll now hand over to my colleague, Evie Neylon, who will begin the demonstration of a neuro-oncology study on RANO, starting from the very first step, data ingestion.
Thanks, Francesco. So let's start where every trial begins, and that's with the data. So we've prepared a demo study for the purposes of today, centered around neuro-oncology. And as the data manager, I navigate to the data tab in our platform, and this is the control room for all your imaging and associated clinical metadata. So here I can see all my subject sessions, and when I access a specific patient, I can see all the metadata information belonging to the patient that has been added so far. When I open the specific session, I can see the uploaded files for the visit, along with the corresponding imaging modalities and tags. And this is the power of our smart uploader tool. So you as the user simply upload the raw data, whether that's via drag and drop or direct from your hospital packs. And our system automatically handles the time-absorbing tasks, such as complete the identification to ensure compliance right from the start, and also full image classification and tagging. And this draws on AI in order to understand the images and labels every series for you. So that virtually eliminates manual user interaction. And the Smart Uploader tool also executes automated quality checks. So you can think of this as an intelligent gatekeeper. It has configurable rules that check for everything your protocol requires, such as, are all the modalities present? Does the image meet specific acquisition criteria for protocols like RANO? And you can view the results here instantly. So this guarantees that only high quality, approved, clean data enters your analysis pipeline. Now, before we jump into lesion annotation, we do need one last filter, and that's RANO eligibility. So even if the images are technically sound from a protocol and integrity perspective, we do need to ensure that they're viable for RANO. So to do this, the data manager simply runs the Image QC and RANO eligibility tool, and you can configure this tool to run automatically on sessions where the protocol is correct, and that just limits any clicks you have to make. So this is a very quick automatic step, and the data manager opens the tool, reviews each of the series according to some predefined criteria in alignment with RANO, such as is there contrast administration present? And then the data manager rates each of the series one by one and verifies, lastly, that the time point is viable for RANO. And once they click submit to confirm eligibility, the image is automatically and securely transferred to our second module, the central review module, and there it's ready for the expert readers. So no more downloading, manually transferring or emailing files. The system executes this handoff seamlessly.
Thanks, Evie. Now I'm starting to enter our central review model as a study manager. And my job is to, as a study manager, is to manage the expert readers and the tasks they are to perform. Our central review model is designed to make my job effortless. I can quickly create a RANO read by selecting the case and choosing the read task type. Notice how the system identifies and stores the number of time points per patient to facilitate longitudinal task creation. I can also create multiple time points and also create multiple tasks at the same time. The capability solves one of the pain points of the complex longitudinal protocols by eliminating the manual task activities required to track progress and assign tasks across multiple time points. So this isn't a list, it's an automating engine for task creation. Now that the task is created, all that's left to do is assign them. So I'll go select the list and assign to reader 5 in this case. To maintain all highest level of rigor and integrity, our solution supports anonymous and blinded readers to eliminate bias. Note that I'm manually doing all of this, but there is a smoother solution. I can access the study and automation submenu. And from there, I will be able to create automations. You can think of it like a task is completed and the next one is created instantly, eliminating manual interaction. or data from a specific site is uploaded and the read task can be automatically created and assigned to particular readers. We also enable notification for a complete and overarching solution. So your readers are instantly alerted when new reads are pending. You're a study manager, but the burden of task management can be kept at a minimum, and your trial moves forward even while you sleep. Now that the tasks are created, we are all set for our research to start doing the work that really impacts your trial, to see what the reader experience when they execute a RANO longitudinal assessment. I'll hand over to Evie.
Thanks. So let's see what life is like for our expert reader using our central review module, and I'll be playing the role of reader today. So the reader's user interface is comparatively minimal. I have my work list where I can see that I've been assigned a RANO read case for 0500 and no other distractions. So when I access this read, I find myself within a longitudinal task environment. This is a core value proposition of this product. Everything is centralized. So as a reader assigned to a case, I can access all available time points for the patient at once, which facilitates comparisons and monitoring. So here I am in the baseline. I can see that for each time point, there's a RANO read, there's an image viewer on the right and a RANO summary form on the left. And the reader's task is clear. Annotate the lesions and complete the RANO form. So first, let's inspect the images. So they've already gone through a rigorous QC process. So filtering the raw data is not something that the reader has to worry about. And control buttons in the toolbar make the interaction with this viewer very simple and intuitive. So here we've selected a T1 post-contrast image on the left for considering enhancing disease and a T2 flare on the right for non-enhancing disease. And they're both in the axial plane. And you can use the toolbar to zoom in and zoom out. You can pan the images. You can rotate like so. And lastly, you can change the windowing. And also there's the potential to change the plane of view. So for the purposes of the demonstration today, a target lesion has already been annotated, TG1. Imagine that something came up mid-read, and now's your opportunity to return to your work and pick up where you left off. Locating this lesion in your image is just as simple as one click, so you can forget the time-consuming scrolling through slices. And to enhance lesion identification further, viewers can link and view the two distinct but correlated images for a complete and comprehensive visualization, like so. So note the auto-registration and the synchronized scrolling here. What about if there are several lesions within the brain, such as in cases where the tumor has metastasized? Well, to annotate another lesion, you simply go back and click the New button. And now a lesion form appears, which is configured to align with the RANO protocol and the information and considerations that the reader has to make. So what we're showing today is based on the RANO criteria iteration from 2010. So the measurements we'll be making will be in 2D. To draw your required annotation, you can select Measure. And this will bring up some perpendicular calipers. And as you adjust the calipers on the image to encompass the maximum diameters of the lesion, the measurements are automatically populated in the form on the left. So in other words, you don't have to input any data manually, so you'll make no transcription mistakes. And on top of that, you will be aware that a key requirement of target lesions in RANO is that they measure at least 10 millimeters bidirectionally. And our system controls for this restriction so that you can only save target lesions that meet this criteria. So otherwise, they're invalid and they must be designated non-measurable or non-target instead. Again, this reduces the likelihood of methodological errors and it eases the reader's cognitive load. So once you've annotated, filled in the form and saved, we can complete the baseline time point and move on smoothly to the first follow-up time point. And this is where the system really shines for longitudinal trials. So every lesion that I added to a time point is automatically suggested in the follow-up time point shown in red. So I can click on the lesion and its details will appear. And then by selecting the reverse clock icon, I can easily reference the original lesion from the initial time point in a new tab. So this allows you to monitor how lesions change over time. And this feature is especially useful if there are many lesions present and tracking them all becomes increasingly complex to juggle. So once I've looked at that, once I have completed and saved the lesion form for the current time point, you can watch what happens. The overall time point response, shown on the left, automatically adjusts. So the platform does the complex calculation of summing the products of each of your target lesions, as well as the response decision tree according to RANO criteria, instantly. So your reader focuses on the imaging and we focus on the math and the tracking. And then this process continues until the reader has completed all the time points and as a final step, reviews the eCRF, or the electronic case report form. So in this form, you can visualize and compare all the inputted information and calculated output responses across time points in one single view. And if you disagree with the radiographic response automatically assigned, for example, you'll likely have access to additional contextual information such as clinical scores or steroid dosage. You as the user retain the possibility of adjusting it, and that's to suit your own informed clinical decision. And a PDF version of the eCRF can also be downloaded for your records or for sharing, and that's shown here. Lastly, the final e-signature is the formal and auditable stamp that formally completes all of these reading activities. But the power doesn't stop once the task is signed off. And a crucial piece of this eCRF, the final response assessment and the core measurements, is immediately transferred back to the platform module as metadata. So the two modules are really highly integrated with results accessible in both to all the relevant users. So the results from the RANO read are combined here in a single view with metadata from other sources shown in dedicated columns here in the data tab, which is right back where we started. And we're going to filter it for case 0500. So the metadata associated with a data session can have several origins. It can be automatically extracted from the DICOM headers of the images, such as date at scan or age. It can be user inputted at the time of upload, such as clinical scores. It can be read generated, such as those from RANO forms, as you've just seen. And lastly, it can be analysis generated. And you might have seen the quality scoring from the eligibility analysis as metadata, but also, and really interestingly, other automated image analyses that have been executing while the manual read was being performed. So you can note there the calculation of total lesion volume that the platform actually automatically extracted for us. And this brings us to our proprietary brain tumor segmentation tool. So this tool offers a powerful capability for precise volumetric analysis of lesions across multiple imaging sessions all at once. It's an AI-powered tool which, once executed, automatically detects and segments all lesions present and calculates the sum of all the volumes and breaks them down into their constituent parts. So enhancing, necrotic core, and edema. So it can be used alongside or to supplement the manual read. And this is an example of how we at QMENTA leverage AI to ease and cut your workload. The resulting volumetric data is then simply placed as metadata within the corresponding data session, and this facilitates comparisons with the target lesion product estimated by bidirectional measurements, for example. The point is that the QMENTA Imaging Hub makes it really, really easy to have a variety of qualitative and quantitative, automatically or manually generated multi-source metrics, all stored in a single environment so you can optimize your decision making. It also means that you can instantly query and export these valuable results in a simple CSV file for reporting or cohort building or statistical analysis. Maybe you're working towards a publication.
Thank you, Evie. Next, we will cover the quality step.
Yeah, so the central review module also provides the robust oversight and auditing steps that are really critical in complex clinical studies. And if your study setup requires it, we can create quality review tasks on submitted reads. This provides the opportunity for the review of a read by an alternative party to the initial reader. So inside this quality task, if the reviewer observes something that they would like to seek clarification for or that they disagree with, they can quickly open queries that are automatically assigned back to the reader, and this creates a direct in-system communication channel. So in the quick example I'm showing, I've opened a new query, added some specific information for the reader to consider, and finally I submit it. Now that the query has been assigned to the reader, we can go back and consider it from the reader's perspective. So here I am logging in as the reader. So the reader can see that within their completed read task, a query has been raised. We can go inside to find the query, address whatever needs to be addressed, change the status, add some response if appropriate, and lastly, we can submit it. And then once we return to play as the reviewer, we'll be able to see that the query has been updated accordingly. So the reader and the reviewer can interact directly until a solution is reached and the back and forth is all documented. And ultimately, it's the reviewer that closes the query. So no more lost emails or untracked feedback. And then once all the queries are closed, the reviewer can approve the time points and e-sign the quality task. And this closes the loop on the review and the input of the reader and the reviewer. And this is just what's happening here with the authentication as the final step.
We will conclude the central review product demonstration with a view of the adjudication solution.
So now I'll round off the entire process just by showing one last step. For instances of disagreement in the reading processes, the system supports adjudication tasks created through a similar simple process. The adjudicator can easily examine any discrepancies within the eCRFs and review each read task individually. So you can enter the task, like here, and see how each reader performed. Once the final resolution is determined, it's formally submitted and lastly, electronically signed once again. So this entire process from the data upload to the final adjudication is now a single, secure and fully auditable workflow.
Thank you, Evie. To summarize the power of the QMENTA Imaging Hub, is what you gain. Regulatory adherence and traceability, simplified task management and study orchestration, longitudinal task and workflow modeling, multi-time point protocols, multidimensional measurement aligned to the reading protocol, built-in quality assurance, and reading result instantly available as structured metadata for analysis. We are now opening the floor for questions. We'll take them from the chat now. See, we have a question. I'm going to read it. How do you ensure compliance with varied regulation concerning storage location in multi-site studies, particularly when different countries and their respective regulations are involved? Thanks to our solution, we offer an adaptable configuration for different locations that allows us to store the data in North America, Asia, Europe, and actually all locations that are available through Google Cloud. And next question, if a new session needs to be uploaded after the reader has begun a RANO task, is it necessary to create a new RANO task? No, our software supports incremental uploads for in-progress read task. For example, if RANO task initially has 3 time points and a 4th one needs to be added, this 4th time point can incrementally be added to a normal upload, and the reader can continue working also on the new time point. Let me see, we have another one. What is the limit for large volume data uploads? and also, do you allow back uploads? So we do allow back uploads, both through UI and API, but with different limits. For both individual and back uploads, through UI, we have a limit of 5 gigabytes, but this limit increased to 19 gigabytes through API. Finally, how long are the audit logs retained for? By default, we retain the audit log for 5 years after the end of the contract, but it can be configured at client request. We are now closing the Q&A session. We will follow up with all remaining questions via email. We want to emphasize that what you saw today is just a snapshot. The QMENTA Imaging Hub supports a wider set of features and already integrates other reading protocol to meet your diverse trial needs. In the meantime, feel free to reach out directly via email or to book a dedicated demo through our website. And if you're attending, please visit us at the RSNA. We would love to meet you in person. With this, we conclude our webinar. Thank you for joining us today and for taking the time to see how QMENTA can accelerate your clinical trials and empower your expert teams. Thank you.